Find the equation of the normal and tangent to the curve. Y raised to the power of 2 is equal to 3x at 0.13. Now, when it comes to equation of the tangent and normal to the curve, the concept is very simple. The first thing we have to obtain is differentiate the function given to you. And this is an implicit function given to us. So let's differentiate what you have on the board. The function is y raised to the power of 2 is equal to 3x. Now, we note that in implicit function, when we are differentiating, we will differentiate x and y variables respectively. But when differentiating for y, always ensure you add the y over the x to it. Attach the y over the x to it when differentiating for y variables. Alright, now if I differentiate this variable, I'm going to get 2y raised to the power of 1. Because I am differentiating for y, I will attach the y over the x to it. Equal to, this is x variable. So to differentiate 3x, I'm going to obtain 3. What is next? Make the y over the x the subject. So I'm going to divide this side and this side by 2y, 2y. This will cancel this, and we are going to be left with dy over the x. So dy over the x is equal to 3 divided by 2y. That is the final solution for differentiation of this function. The next thing we must obtain is to get the gradient of the tangent and the gradient of the normal respectively. To get the gradient, always ensure that you substitute the point given from the question into dy over dx. So that becomes gradient of tangent to the is equal to, and m1 at dy over dx will give 3 in bracket 2. This point is for x, whereas this is for y, and on the board we have 3 over 2y. X variable is not found in dy over dx, so we are only going to make use of 3, which is that of y. So let's substitute 3 in place of y. So this will give, so we obtain 1 over 2 as the gradient of the tangent. So the equation of the tangent is given as y minus y1 is equal to m1 x minus x1. So y minus y1 is 3 equal to, the gradient is 1 over 2, x minus x1 is 1. So we have 1. Y minus 3 is equal to, if I open the bracket, I'm going to obtain x minus 1 over 2. So by cross multiplication, if I cross and multiply from this point, then it will become y minus 3 is equal to x minus 1, and 2y minus 6 is equal to x minus 1. 2y minus x is equal to minus 1 plus 6. So 2y minus x will equal to 5. This is the equation of the tangent. So 2y is equal to x plus 5. This is the required equation of the tangent. Up next, we have to determine the equation of the normal. And to do this, the first thing we have to obtain is to get the gradient of the normal before obtaining the equation of the normal. Let's get the gradient of the normal. Gradient of normal M2 is equal to minus 1 over M1. So that is, it will give minus 1 over M1, and M1 was given as 1 over 2. So let us evaluate what we have here. This is basically the same as minus 1 over 1 for the numerator divided by 1 over 2 divided by 1 over 2. So minus 1 over 1 times, when you introduce a multiplication sign, it becomes the reciprocal of the next term, which is 2 over 1. So minus 1 times 2 gives minus 2 over 1. So the result is minus 2. M2 is equal to minus 2. At this point, you can determine the equation of the normal. So the equation becomes y minus y1 is equal to M2 in bracket x minus x1. Y minus y1 is given as 3 is equal to M2 is minus 2 in bracket x minus x1 is 1 at the point. This is y minus 3 is equal to minus 2 times x is minus 2x. Minus 2x minus 2 times minus 1 is plus 2. Alright, we have y minus 3 is by a collection of like terms. If I collect like terms, then y is equal to 3. When 3 crosses over, it becomes plus 3. Then minus 2x plus 2. Therefore, y is equal to 3 plus 2 is 5. 5 minus 2x. And this is the equation of normal to the curve. So the equation of the tangent is given as 2y is equal to x plus 5, and equation of normal to the curve is y is equal to 5 minus 2x respectively. So that answered the question on the board. If this video was really helpful to you, click on the subscribe button if you haven't subscribed, and also share this video. Also, in our next video, we are going to consider one of the most important aspects of application of differential calculus, and see you in our next video.